Okay, you're live. Okay. Okay, fine. Hello, let the people come. Hello, everyone. My name is Sanjana Das, and I am a master's in physics. I have an experience in teaching for past 5 years, and also I love writing. I love writing books. I love creating content, and all of these things. So today I am going to. I also work for Letstute, and Letstute is this place where we are creating a lot of content for you. So, everyone who's watching this, welcome to Let's Tute. Also, if you haven't subscribed to our channel, then do subscribe. And don't forget to press the bell icon to never miss an update from us. We have a lot of courses in science in our website, www.letstute.com. So, do visit it. Okay, fine. Hi, Anirudh. Hi, Shweta. Okay. Yeah, hi, Anirudh. So, just a quick recap. My name is Sanjana for people who were not there. My name is Sanjana, and I will today try to cover from the chapter Work and Energy. I'll try to cover what is energy. Also, there are two important derivations in physics that come a lot, and that is what is the derivation of kinetic energy, and what's the derivation of potential energy. So, we are going to cover that as well. What's kinetic energy and what's potential energy. So people who are watching this and have not subscribed to our channel, please do subscribe, and it gives you a lot of various content. And so let's start with today's topic. Let's start with energy. So before starting with energy, I had already taken one more live last time. You all can go to the channel and check. So I have spoken about work done. Yeah, hi Swapnil. So we have spoken about work done. We know what is the formula for work done. We know what is the definition of work done. What are the different types of work done. So those concepts are clear. I'll just quickly try to explain you what it is. Okay, fine. So I'll just quickly try to explain you what is work done and what are these. So from the chapter Work and Energy, we have learned that work is said to be done when the force in question produces a displacement. And we've also known what is displacement. Displacement is the shortest path. Also, if you're just standing there and looking at the video, you are actually not doing any work. Your work would be done when the force in question, yeah. So your work would be done when the force in question actually produces a displacement. So all of these concepts are actually learned. So this guy, if he's just standing there, work is not done. If he moves only, then we'll say that work is said to be done. Also, we had the formula for work. Now, this is very important for our today's lecture. What is the formula for work? Because we are going to use this formula to derive what is kinetic energy and what is potential energy. Yes, work is said to be done when work is to do harder and also smartly. Okay, Swapnil, I get your definition. Okay, so guys, understand one thing. This formula is very important for your definition of kinetic energy, for your derivation of kinetic energy and your derivation of potential energy, because A, it does come in your exam. Yes. Hi, Swaranjali. So it does come in your exam. Also, what comes is the factors affecting it. They will give you a lot of numericals based on these formula. So let's just quickly start. What is energy? Now, to understand energy, let's take an example. Now, when we are doing all of these things, we have learned different types of work done. Now, let's understand what is energy. Now, to understand energy, let's say there's a very small girl, and there's this huge guy, and both of them have been given some work. Their work is to move this box. Their job or their work is to move this box. So if they are yeah, Anirudh, you can ask any question. It can be in the chat section. I will teach for 10 to 12 minutes. Yes, I will teach for 10 to 12 minutes, and after that, I'll have a chats. I'll have a proper doubt session, so y'all can just quickly tell your friends that there would be. And I have an experience in teaching physics for past 5 years. I've been training people to give the board exam and all. So if you have your friends, quickly tell them there would be a doubt lecture. There would be a doubt lecture within this time. So after finishing, after teaching you this concept, I will solve all of your doubt. So now, to understand energy, there is this small little girl, there is this big guy, and both have been told to do work. They have to move this body. Now, common sense, if I tell them move this body, so this small little girl, her capacity to do work would be less. And comparatively, there is this guy who's actually eating so much. So for them, their capacity to do work would be so much, right? For this guy who's actually eating so much food, for him, his capacity of work is very high. So based on that, I can say that the girl's capacity to do work is less, and the boys or the man's capacity to do work is more. That is, the small, tiny girl, the small little girl has less energy, and the big, huge guy has more energy. That's what is energy, by the way. Energy is the capacity to do work. Now, once again, what is capacity to do work? It's energy. This means how much can you work. Now, what does it depend on? It actually depends on how much of food you're eating or how much of energy any body has. If you are eating, that's the reason our moms tell us eat a lot of food. So if you're eating a lot of food, you're actually having a lot of energy. Now, because you're having a lot of energy, you can do a lot of work. Now, to explain this concept, yes. Now, to explain this concept, let's take a simple example. Now, there's this bowler. Let's say one fine day he had very much to eat. He was like he had exercised well and he has a lot of energy. So he puts a ball, and we notice that the displacement is a lot. Then another fine day, maybe he has very less energy. So because he has very less energy, he puts the ball, but the displacement is very less. Once again, when he had more energy, his displacement was high. Because his displacement was high, the work done by that boy or the work done by that baller was a lot. Second case, when he is actually having, let's say, less energy, the displacement is also less. And because the displacement is less, I will say that the work done is less. This means work and energy are actually interrelated. Once again, this is an important concept because formulas are based on this. Energy and work done are interrelated. If you have more energy, you will be able to do more work. And if you have less energy, you will be able to do less work. So, therefore, work and energy are interrelated. This means the unit of work and energy would be same. Now, for people who were not there in the last live stream, I have already explained you the SI unit of work done is energy. Same, sorry, is joule. Same way, the SI unit of energy is also joule. The SI unit of the CGS unit of work done was ERG. Same goes with energy. The CGS unit of energy is ERG. This is something which comes in your exam, and if they tell you what is the relation between the SI and the CGS unit of energy, remember once again SI unit is joule and CGS unit is erg. Now, after learning that energy, once again, let me just repeat, energy and work are interrelated, and energy is the capacity to do work. Now, after that, the question comes, what are the different sources of energy? The different sources of energy. We have been learning it from a very young age. What are the different sources of energy? Where do you get energy from? The picture tells you where you're getting energy from. Yeah, people, the main source of energy is the sun. The sun is the main source of energy. In fact, inside the sun, when you're reading more about it, you'll know inside the sun, it's there are different atoms, and there are different nucleus and all, which combine together to form a lot of energy which comes to us. So the main source of energy is sun. But sun is not the only source of energy. Your atoms can also give you a lot of energy. In fact, your winds can give you energy. Your tidals can give you energy. Your tides are actually used to form to get energy. The core of the earth. Nowadays, scientists are trying to, yes, Anirudh, you're right. Food is a form of energy. In fact, food, Anirudh, is a chemical energy, because when you're eating, you're actually taking in chemical energy. So, very good, Anirudh. Food is also type of energy. Now, one more thing, remember, scientists are actually doing a lot of experiments to get Earth's energy. Now, inside the core of the Earth, everyone knows it's very, very hot. Now, because it's very hot, okay, because it's very hot, what happens is, so because the energy is so much, okay, um, scientists are trying to find a way scientists are trying to find a way to take energy. Scientists are trying to use a way to actually take energy from the core of the earth. So that is one of the sources of energy. Now let's understand what are the different forms of energy. Now the different forms of energy, like let's take the easiest one. The easiest one, or the easiest form of energy, is heat energy. We get heat energy from a lot of different places. In fact, we get heat energy from the sun, we get heat energy from the candles. There's also tidal form of energy. So your tides and all your waves have energy. Once again, scientists are trying to use this tidal energy to produce electricity. So yeah, research is going on. There's a lot of research and all. But yeah, scientists are trying to take energy from tides. Now there's one more form of energy, chemical energy, which Anirudh, you were saying, that is food is a form of energy. Food is a form of energy, and food is a source of energy, and the form in which it is obtained is actually chemical energy. But today I'm going to talk about two more important forms of energy, that is the kinetic energy and the potential energy. What is kinetic energy? What is potential energy? And like, why are they so special? Why is it that in this chapter we are giving so much of importance to it? Remember, kinetic energy and potential energy are actually energy of an object due to its state and due to its motion. It actually tells their kinetics. Due to their kinetics, they have energy. That's the reason sometimes a lot of teachers, rather than saying kinetic and potential energy, hi Swarna. So rather than saying kinetic and potential energy, some teachers will directly tell you mechanical energy. Don't get confused. Mechanical energy is something which is kinetic and potential energy together. Mechanical energy has two types, that is kinetic and potential. We are going to learn more about it because according to your CBSE curriculum, these are the two topics which are very important. They have given a lot of importance to this curriculum topic. So before learning about kinetic energy and all, let's take this example. Now there is this hammer above a nail, and it's very simple. The hammer isn't working. I have just taken this hammer and put it above the nail. So because I'm putting the hammer above the nail, tell me, will there be any work? I have not moved the hammer. I have just placed the hammer above the nail. That's it. I have just placed the hammer above the nail. So obviously the hammer is not moving. And because the hammer is not moving, it is not doing any work. The hammer is not doing any work. But let's take one more example. Now let's take this hammer and move it above the nail. When you're moving it, when you're moving the hammer above the nail, what happens is due to the movement, the nail goes inside. That is, there is displacement. Yes. So, because there is displacement, okay, so because there's displacement, I'll say that work is said to be done. Once again, remember when the hammer was moving, okay, so when it is moving, the nail is moving. That is, there is displacement. That is, work is said to be done. This means the moving body was actually doing some work. Now, this means that the moving body had energy. Once again, for people who didn't understand, the moving body or the hammer which was moving was doing some work. This means that any moving body will do work. Now, because it is doing work, it must possess some energy. Now, that energy is called as kinetic energy. So kinetic energy is energy of an object due to its motion. So if an object is moving, that is because it possesses kinetic energy. But at the same time, okay, at the same time, if a body does not move, initially if it is not moving, I will say that the body does not possess kinetic energy. So let's take some examples of kinetic energy. A moving car is an example of kinetic energy. Moving wind is an example of kinetic energy. In fact, friends, it is the kinetic energy of the wind which turns the turbine, which in general or which in result produces electrical energy. It is the kinetic energy of the water in a waterfall which turns the turbines. So when the turbines are rotating, electrical energy is generated. This means moving body possesses an energy, that is kinetic energy, due to which we get so many different things. Now, so we know that the moving body consists of, has some energy, and it is kinetic energy. Now let's go one step further. Let's find out the formula for kinetic energy. Very, very important, a derivation which your teachers, yeah, thank you, Anirudh. So, very, very important, a derivation which a lot of teachers love asking. They're like, easiest question, they'll tell you derive kinetic energy. Or one thing that they can do is they'll tell you to give the formula of kinetic energy. Now, how do you give the formula of kinetic energy? To find out the formula of kinetic energy, today I am going to derive the formula. Normally we just take it from somewhere. But today I will derive the formula of kinetic energy to make you understand how we got it. So it will actually make your work easy. Now for deriving the formula of kinetic energy, what we will do is we will take a body of mass m. Okay, a body of mass m, and initially, let's say initially the body is moving. So if the body is moving, so obviously if it is moving, it has some amount of velocity. And because it's initially moving with a velocity, we have already done it. It's called as u. Let's denote it as initial velocity u. Now, when we apply force, the body changes its velocity. So when the body changes its velocity, let's say finally the velocity of the body is v. Once again, initially it was moving with a velocity u. After applying force, the body moves with a velocity v. That is, if you notice carefully, there is an acceleration denoted by a. Once again, initially the body was moving with a velocity u, and finally it is moving with a velocity v. That is, there is an acceleration a due to the force F. And obviously, when the body is moving, it is displacing. So let's say the displacement is S. I'm trying to get all of the concepts clear. And to understand all of the concepts, these are all the variables that I'm going to use in the derivation. So a body is applying force on another body. Let's say the force is F, denoted by capital F. Okay. Now, when you're applying force, maybe initially the body was moving with a velocity. Let's say that initial velocity is u, and because you are applying force, the body is going to change its velocity. So let's say its final velocity is v. Obviously, there has been a change in velocity, and change in velocity is called as acceleration. So let's say the acceleration is a. Last, the body obviously displaced, right? The body moved a certain distance. So because the body moved a certain distance, so there was a displacement, let's denote that displacement as s. Now let's come to the important concept to find out the formula of kinetic energy. Once again, remember, energy and work are interrelated. So if I find out the formula for work done, I will actually find out the formula for kinetic energy. So that's why I told you, remember the formula, remember the formula. The formula for work done is force into displacement, that is F into S. Now out of that, remember, force has a very simple formula. I love saying this. The formula for force is ma. Ma means mass into acceleration. So once again, the formula for force is ma. Ma matlab for mass and acceleration. Mass into acceleration. Now let's try to. So force ka formula is mass into acceleration. If someone tells you what's the formula for displacement, S. To find out the formula of displacement, we have to do slightly a little more of work, and we are going to use the third kinematical equation. It's there in your motion chapter. So from your motion chapter, the third kinematical equation, which is v square equals to u square plus 2as. V is the final velocity, u is the initial velocity, a is the acceleration, and s is displacement. So v square equals to u square plus 2as. But if you look carefully, you have to find out what is s. Now to find out what is s, I have to use this formula, okay, and I have to change this formula to get it in terms of s. So what I do is very simple. This u square, which is plus over here, I send it the other side. So here it is plus. When it goes to the other side, it gets minus. So it will be v square minus u square. But then I also don't want 2a because I just want the formula for s now. So 2a, which is getting multiplied here, when it goes to the other side, it gets divided. So now the formula for s, look carefully, the formula for s is v square minus u square divided by 2a. How did I get this formula? Simple. U square, which was getting added there, I changed, I brought it this side. So it was v square minus u square. And 2a, which is getting multiplied there, I brought it this side. So it's getting divided. Thus, I get the formula s equals to v square minus u square upon 2a. Now, quickly, both of the values of force and displacement, I'll put it here. So force, once again, force is mass into acceleration, that is ma. And s, in place of s, you will write v square minus u square divided by 2a. 2a is in division. So when you're substituting all of it, look carefully. Look carefully, m into a into v square minus u square divided by 2a. So there's something which is common. Look carefully, a is in the numerator and a is in the denominator. So if a is in the numerator and a is in the denominator, I'll do a very simple thing. I'll cancel a from both the sides, from the numerator and the denominator. You must have done it in your math. So a in the numerator and a in the denominator gets cancelled, and finally what you get is half m into v square minus u square. For students who didn't understand this, I'll repeat again what I did. I took the two formula. This is force ka formula, mass into acceleration. This is your displacement ka formula, v square minus u square upon 2a. I substituted both, but then a, which is in the numerator and in the denominator, I cancel them. So now when I'm cancelling them, I get m into v square minus u square divided by 2. Now this divided by 2, I bring it front. So I get it as half because 2 was in the denominator. So therefore W is equals to half m into v square minus u square. This is very, 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 very important because this is the formula for the work done on a body due to its motion. Now look carefully. This half mv, I can open this bracket and multiply it to both of them. I can multiply it to v square also. I can multiply it to u square also. So let's multiply it to both. Once again, cancel a, bring 2 forward. You get half into m into v square minus u square when you are multiplying it with both. So it is half mv square minus half mu square. This is the formula for the work done by a moving body. Or in general, this is the formula for kinetic energy. But remember, this formula works only when the body is initially moving at a certain velocity. What happens if the body was initially at rest? I am waiting for your answer. Till then, I'll revise it. Tell me, if the body is initially at rest, which velocity will be zero? V or U? I want the answer in the chat section. All of you, if you know the answer it in the chat section. The body is initially at rest. So if it is initially at rest, what velocity will be zero? V or U? I'm waiting for your answers. Come on. By the time you all are answering, once again, I'll just quickly revise what I did. I said work done is force into displacement, force is mass into acceleration, and displacement is v square minus u square upon 2a. Substitute it, a gets cancelled, and when a gets cancelled, you take 2 forward. When you're taking 2 forward, what you get is half into m into v square minus u square. Then you open the bracket, and finally what you get is half mv square minus half mu square. Anirudh, you're saying that v is 0. Remember, Anirudh, the initial velocity is 0. The body was initially at rest. If the body is initially at rest, this means that the initial velocity is 0. That is, u will be 0. Because the body is initially at rest. Initial velocity is denoted by u. So u will be 0. And because u will be 0, the whole term, the second term will be 0. So finally what you get is half mv square. Half mv square is the formula for kinetic energy when the body is initially at rest. I am putting a lot of pressure in these sums because they are important. They come in your exam. So once again, when a moving body does work, you call it as kinetic energy. The formula for kinetic energy is half mv square. When will it be half mv square? When initially the body is at rest. Okay? Now let's go one step forward and learn what happens when a body is actually not moving, when a body is at a particular state. So for this, you can take the like these toys which we used to play with when we were young. We used to win this toy, and then when we used to leave it. So when we are leaving it, the toy used to bang itself, like as in there were like hands, and it used to bang itself. Also, there is one more toy with which I used to play when I was young. There was this car which I had to put backward. So when I'm pulling this car backward and when I release this car, the car moves forward. So all of these things, so all of these two toys, today we'll understand the physics behind the working of these two toys. Now for that, let's understand that there was some energy stored inside these toys, which later on converted into the moving, that is the kinetic energy. So this stored form of energy has a name. It's called as the potential energy. Once again, if someone questions you, what is this stored form of energy called? Stored form of energy is called as potential energy. In fact, energy of an object due to its state is potential energy, and potential energy is always stored. One best example for that is bow and arrow. So when you're stretching the bow, what you are doing is you're doing work on that bow. So when you're stretching it, you are doing work on that bow, and that energy is stored in that bow. So now when you're releasing it, the bow moves. Now when it moves, now once again it's converting into kinetic energy. Once again, understand, when you're stretching a bow, you are doing work on it, and that energy is getting stored in the form of potential energy. But now when you release it, the bow moves. And when the bow is moving, It is doing kinetic energy. This means this stored form of energy, it has a name. This is potential energy. So energy due to its state. Now the question comes, what are the different types of potential energy? It is there, like completely it's not covered, but I'll tell you there are two forms of potential energy. One form of potential energy which we have done a lot, that is elastic potential energy. You must have seen it in those elastic bands and like all of those games that you play. So the rubber bands and all of them actually store elastic potential energy. But then there is one more form of energy, and that is gravitational potential energy. That is energy of an object due to its height. So if you're taking water, waters are stored in dams. So what is it actually doing? It is storing the water at a certain height. And because it is storing at a height, it is storing energy, or it is storing gravitational potential energy. Later on, when you open it or when you let the water fall down, then it gets converted into kinetic energy. So one more last derivation of the day. Yeah. So last derivation of the day. The derivation is gravitational potential energy. If someone tells you what's the derivation of gravitational potential energy, so gravitational potential energy is energy of an object due to its height. Okay. Now to find out that, let's say there is like a body at a certain height, and obviously it has a certain mass. Now obviously because it's at a height, let's say the value, the displacement is h. Once again, don't forget the formula for work done. The work done's formula is force into displacement. So if you want to find out energy of an object due to its height, remember when you're picking that object upward, okay, when you're picking that object upward, you are actually doing work which is getting stored in it. So just find out what is that work. So when you're picking an object upward, what you're doing is you're storing work or you're storing energy. Now the force is equal to mg. So why is force equal to mg? You all have done the formula for force. Force is mass into acceleration. But the problem is that acceleration is equal to g. That is acceleration due to gravity, because you're doing it against gravity. So therefore, in place of force, you will write mg. Now let's talk about displacement. When you're taking a body and picking it upward, you're actually displacing a body to a certain height. So in place of displacement, you will write h. Now quickly just substitute both the formula. In place of F, you will write mg. In place of S, you will write h. And thus you get the final formula for gravitational potential energy, that is mgh. With that, we are done with today's explanation. Let me give you a quick recap of what I did. I explained you about energy. I've explained you about potential energy and kinetic energy. If you want more videos, we have like in Letstute, we have our own website www.letstute.com. You have more videos based on same concepts. We have a lot of numerics solved on these concepts. So do visit the site. There are numerics based on these. You will get a lot of numerics where it is like also we are trying to solve a lot of questions which have been asked before. So do visit the site. Once more, a quick recap. We did energy, we did what is kinetic energy, and we did what is potential energy. Okay, so with that we are done. Does anyone have any questions? Wait. Yep. Does anyone have any question? Swarna, do you have any question? I'm going to solve physics questions. If you have any physics related questions related to motion or related to energy, y'all can ask me, or within 5 minutes, I'll stop with the live. So y'all have 5 minutes to ask me questions related to physics. Related to physics, you all can ask me questions, and if those are physical, like If they are normal conceptual questions, I'm going to solve them. You have last 5 minutes to ask questions. You all can tell your friends to ask me questions. If you all have any questions, you all can ask your friends. They can come and ask questions, but then you have just 5 minutes. Please do ask questions. Okay, I think I'm not getting any questions. You all can ask me work, the chapter work and energy. In fact, you all can ask me physics related questions. You all can ask me for any other chapter as well. But then work and energy is something that we are trying to cover. Okay, you have a doubt, Shiva. You have a doubt. Yeah, guys, Shiva, what is your question, Shiva? Shiva, you can ask me any questions. Yeah, guys, Shiva, you can ask me question by that time. By that time, remember, y'all, please do subscribe. Okay, it is a big question. Okay, fine. Fine, Shiva, I'm waiting for you. Um, I'm waiting for you, Shiva, for your question. And please do subscribe to our channel. You'll get more such content. And don't forget to press the bell icon to never miss an update from us. And we have a lot of courses, obviously. And yeah, Shiva's writing the question. We can wait for Shiva. By that time, if someone else has any question, concept of buoyancy. Okay, fine, Chandra. By the time Shiva's asking me that question, I can explain you what is buoyancy. So buoyancy is a very simple concept. Obviously, if you're putting a body, okay, in liquid, remember, yes, good, Chandra. So remember that if you're taking a body and if you're putting it in liquid, that liquid has some amount of force, it has some amount of resistance. We have learned about friction. So buoyancy is very simple. When you're taking a body and putting it in a liquid, the liquid will apply an upward force. That upward force is called as buoyancy. That is the basic. Now, based on the liquid, the buoyancy level changes. If you have a liquid with a higher density, obviously the buoyancy will be more. For example, if you're taking and if you're putting a body or if you're putting a ball in in honey, so what happens is honey is a very dense liquid. So because honey is a very dense liquid, its buoyancy or its upward force. By the way, the definition for buoyancy is upward force. So its upward force increases. But in that case, if you're taking a less denser body, for example, if you're taking kerosene. Now kerosene, everyone knows that compared to honey, kerosene has a less density. So there, if you're putting the body or if you're putting the ball, remember the upward force would be less. So that is the concept of buoyancy. In fact, Archimedes said a lot of things. And remember, whatever force is applied, it depends on a lot of things. One thing that it depends on is the density of the liquid. If you're putting more dense liquid, okay, if you have a more dense liquid, then obviously if the density is more, then the upward force would be more. Also, next thing that you should know is the body which is being put in it. Let's say if the body has a higher density or if the body has a higher weight, still the upward force would be more. Shiva, I'm waiting for your question, Shiva. Shiva, by the time, like I'm explaining Chandra, but I'm waiting for your question. So yeah, so I was explaining buoyancy. Buoyancy is very simple. Don't worry. I know a lot of people, like they get very upset. Like, oh my God, buoyancy is so difficult. It's not difficult. Just understand. You take a body, you put it in a liquid. The liquid will apply an upward force. The liquid is trying to put it upside. That is called as buoyancy. Now, based on the density of the liquid, the force applied would be different. If it is more, if the density is more, the upward force would be more. If the density is less, the upward force would be less. That's it. That's it. Nothing more. If you have any particular question, okay. The time taken to perform 440 joule of work at a rate of 11 volt is, okay, you want to find out the time. So you have been given a rate of 11 watt. Fine. So Piche, you've put 11 watt. That means that is power. So they've given you P. Okay, they've given you P, and they've given you W, and you have to find out what is. Yes, yes, Shiva. I will tell you, Shiva. I'm trying to answer that only. So everyone, whoever can see Shiva's question in the chat box, Shiva has asked a question where they are like, where he said, or where she said that what is the time taken to perform 440 joule of work. W ka value they've given as 440 at the rate of 11 watt. Rate matlab your brain should be clear. Rate of doing work, I have not covered that topic. It would be in the next live session, but still I'll solve it. The next is the rate of doing work, that is power. So they've given power is 11 and they've given work is 440. So power is 11. If you are doing the formula is very simple. The formula is P equals to W upon T. Once again, P equals to W upon T, where W is 440 and T is 11. So if you want to find out time, just everyone who has a book with them. If you have a book with you, what you have to do is, let's see if I have a book with me or no. Oh, I have a book. I'll just try to do it in front of you. Okay. So P, I don't think so if you're able to see it, but we have P and we have P equals to W upon T. So if P equals to W upon T, okay, if P equals to, I don't think so you're able to see it. So if P equals to W upon T, okay, and if you want to find out what is T, you're going to cross multiply it. So when you're cross multiplying, T will be equal to 440 upon 11. That's it. Just do 440 upon 11, you will get your answer. And 11 fours are 44. So your answer would be 40 seconds. Once again, your work done is 440. Your power is 11. You have to find out what is time. Just use the formula power equals to work upon time. Work will be 440. You have to find out what is time. And they've given you what is power. Just cross multiply it. When you're cross multiplying it, finally you will get T equals to 440 upon 11. And 440 upon 11, 440 upon 11, yes, yeah. Thank you, Chandra. So 440 upon 11, 11 ones are 11, fours are 44. And then the 0 is added. So therefore it is 40. So the time taken, Shiva, the answer is the time taken is yes, 40 seconds. So I'm done with that. Are there any more questions or I'll just log off? I'll end the live. So any more questions, guys? Any more questions related to physics? If you have any, you can ask me. I will try to solve them. And please don't forget to also, we have one more live, I guess, based on these topics, based on power. If you want, I can try to solve some numerics, because I understand that you're having problem with numerics. So just to comment, Letstute mein we are going to put up next live session, whatever you want, whether you want it in a numerics form, whether you want me to solve numericals or you want me to solve board questions, tell me, comment about it. You all can comment about it now. I'll try to take it next Sunday. So next Sunday we can have either power, a numerical based on power, or lecture based on power, or a lecture based on just numerics taken in board. We'll try to solve some board questions. So you all can just comment. And with that, I'll end the live. Whatever you want. Last 2 minutes to comment whatever you want. And after that, I'll end the live if I don't get any replies. Okay. Shiva, the answer is 40 seconds. Shiva, the answer is 40 seconds. Just do 440 divided by 11. The answer is 40 seconds. Anything else, guys? Okay, so a man pushes a wall and fails to displace it. Okay, I saw this question now. A man pushes a wall. This is something which I have explained last time. Remember, I am pushing a wall. I'm applying a lot of force, but the wall is not displacing. So because the wall is not displacing, I'll say that the work done is zero. Once again, I am pushing a wall, I'm trying to displace the wall, but then the wall is not going. The wall is not displacing, and because the wall is not displacing, I will say that the work done is zero. So, yes, Shiva, the work done is zero. Anything else? That's it for the day. That's it for the day, guys. Bye. Bye, everyone. Don't forget to subscribe and tell us what do you want next. You all can just comment on our videos. What you can comment in this video later on, whatever you want. I will try to bring those things. I will try to bring those numerics. Okay, guys. Bye. Please don't forget to subscribe. Bye, Shiva. Bye, Chandra. Yes, chalo. Bye.